We're going to be beginning Unit 2 today, looking at relations, functions, and linear equations. We want you to be able to identify relations, including stuff called the domain, the range, x and y intercepts, and also what defines a relation as a function. This table on the right here shows that we have some different types of animals, and it compares their average lifetime in years to their maximum lifetime in years. This data could be represented as what is called an ordered pair. And an ordered pair always has an x value first and a y value second. So if we're looking at our table here, we got an x and a y value. We could represent all of these as ordered pairs. The cat ordered pair would be the ordered pair 12, 28. The cow we could represent as 15, 30, and so on all the way down, with each x value going first and each y value going second. You kind of get the idea. Okay, so if we take these 5 ordered pairs now from the table, we can identify different things. One being the domain. And we identify the domain as your set of all first coordinates. And we know that the first coordinates are really your x's. Okay, so it's all your x coordinates. Another word, range, that's the set of all the second coordinates. Or another way of saying that, then, we know all our second coordinates are our y coordinates. So domain is a fancy way of saying your x's. The range is a fancy way of saying your y's. Okay. One other term we're going to be looking at is a function. And a function is a relation in which each element, and an element is just the numbers here, so like 12 and 20, all these numbers are elements. Each element in the domain, that's our x's, pairs with exactly one element in the domain. Or sorry, in the range. We already used domain. In the range, our y values. It's kind of a lengthy definition, but function, each element in the domain pairs with exactly one element in the range. Let's look at an example of what that would look like. Here is a mapping of what we have here. So the domain, okay, has all these numbers here. That's our x's. Our range, remember, that's our y's. A mapping of one to another would indicate a function. So this, we would say, is a function because each thing here, each thing in this one pairs with one thing in this one. Okay, that would be considered a function. There's another way of seeing if something is a function if it's graphed out, and that is what's called a vertical line test. So if you got a graph of a function, no vertical line can intersect a graph in more than one point. That's going to represent a function. So this first one, if we draw vertical lines in here, notice how our vertical lines, no matter where we draw them, only hit the graph at a single location. That indicates that this is a function. On this second example, if I draw a line right here through 4, you can see it intersects at 2 places. We would say that this then is not a function. The reason being is we have a point right here at the location 4, 2. There's another point here at the location 4, -2. If I were to draw it similar to how we had here then, with our domain and our range, if I have the value 4 in here, 4 is going to two different range values. That is not the definition. The definition says our domain here can only go to one value in the range, not two. So this we would say is not a function right there. Okay, using your calculator, we want to be able to look at some of this stuff with the graphing calculator. Is this equation y equals 3x squared minus 5, would that be a function or not? Well, to graph something out on the calculator, if you have like a TI 84 or 85 84 or 83 calculator, hit the y equals button, which is kind of in the upper left hand corner, and then you want to type in this graph here. Okay, to do that you type in 3, okay, x, there's a button kind of right in the upper left hand corner here that says x and t, and that one we can use for x. We got to do a power of 2, so exponent power 2, and then minus 5. And then if we hit this graph button in the upper right hand corner, we should get a picture of a graph of this function. So now, would it be a function? Does it pass our vertical line test? I think so. If we draw some vertical lines here, no matter where we draw vertical lines, it only hits one time. So we would say yes, this would be considered a function. Okay, let's look at some other ones here. Would these be considered functions? Let's graph them out the same way. So again, go to your y equals menu, type them in. Let's type in square root of 1 minus x squared, and then also square root of, negative square root, negative square root of 1 minus x squared. If we graph these ones, okay, you kind of get that. It's a little bit harder to see. If you hit the zoom button, we can either zoom in, or this number 4, this decimal graph, can kind of zoom in on it. It looks like together these two graphs make a circle. Would this be a function? Nope. If we draw our vertical line, it looks like it hits 2 times. So this combined graph is not a function. Would it be a function? No. All right. Now back to your note sheet here. They want us for these graphs here to state what the domain and range is. Domain and range you can list as individual points if it's a relation like this. So a domain on this one would be all our x values. Any x value we see would be in the domain. So we'd have -4, -3, 0, and 1 would be our domain. Our range is our y's. That would be the set of all the y points here. So here it would be the ones listed. Now usually they list them from least to greatest. Looks like our smallest one here is -2. Our next biggest y value there is 0, 1, and 2. So that would be the domain and range. On number 2, state the domain and range on this one. Domain here, again, we want to list all the x values. So if you go in order, it looks like the smallest one there is -4. Next biggest one is -3. 0 is the next biggest one. Oh, sorry, no, there is no -3. I'm looking at the wrong thing. Next biggest one would be -1, then 0, then 2, then 3. Range, that's our y values. So the smallest one looks like -4, then -3, -2 is another one. And then 3 shows up twice. Now, if it shows up twice, we don't need to list it twice. We only need to list it one time. Okay, now it also asks us to state whether these are functions or not. So let's go back and look. Is the first one a function? Does each element in the range, does each domain value go to a separate y value? And here I think it does. There is no repeated x value. So since there's no repeated x value, we don't have to worry about it going to a different y value. So this one definitely is, yes, this one is a function. Is the second one a function? I believe so here. I don't think we had any repeated x values in here. None of these x values were the same. And so this one should be a function. We could also look by the vertical line test. We draw vertical lines. Do any of these vertical lines through these points pass through another point? Nope. And so yes, this one would always also be a function. Now some of you might have thought for the second one, no, because we got 2 3s here. It's okay to have 3 pop up twice. Just can't be our domain value. You can have the same range value, just can't have the same domain value. All right, some other notes on functions. We said before that if a relation is a function, you can then say that our y value is also the same as what's called f of x. And this is called function notation. Okay, function notation, instead of using y, they use this notation f of x. It means a function with the variable x as its independent variable. Independent means the x variable, the domain. The dependent variable in this case would be y, or f of x, because that changes depending on what you put in for x. So to solve a function like this example here, they want us to find what's f at -3, which means this function, which is x squared plus 2, is going to be equal to something depending on what we put in for x. Here we're going to replace the x with -3. So at -3, this function is going to be equal to -3 squared plus 2. So we're replacing this x with this number. Now we got to evaluate that. -3 squared, -3 times -3 is 9. If we add 2 to it, we get 11. That would be the solution to this problem. We don't have to do anything with this -3. That's just the notation. That's saying this function at -3 equals 11. Or another way of saying that is if you plug in -3, you get 11 as your answer. It's the ordered pair 3, 11. That's the point on the graph that is associated with this point. -3, 11 would be the point right up there. Okay, so that's what that means, is at the point -3 you get a y value of 11. All right, let's look at some more of these. So now we're on the back of your note sheet. Given that g of x equals this, find the following. So first they want us to find what is g at 2. Okay, so similar to what we just did, we want to now replace any x with 2 and see what we get. So we get 3, there's an x, so we want to replace it with 2. There's another x, so we also got to replace that one with a 2. Now you just got to simplify that. Okay, follow order of operations. Do we have exponents? Yep, 2 squared, 2 times 2 is 4. Do we have multiplying? Yep, 3 times 2 is 6. If we subtract them, we get 2. So the answer is 2. Or another way of saying this is there's a point at the location 2, 2. All right, part B. Here they want us to find a different one. They want us to find what is g at 3 times g at -1. All right, so there's 2 functions we're going to have to find here and then multiply their values together. So g at 3 means we got to plug 3 into this. So let's see what g at 3 is. g at 3 would be 3 times, we're plugging 3 in for x again, same function up here, minus 3 squared. So 3 times 3 is 9, 3 squared is also 9, looks like that equals 0. Okay, why don't you pause the video quick, see if you can figure out what g at -1 would equal and see what you get. All right, let's see what you add. 3, we got to plug -1 in for x. We're also plugging -1 in for this other x and simplifying it. We multiply those, that's -3. Now be careful here, don't double slash. It looks like we could maybe double slash there, but you can't because there's an exponent. Double slashing is like multiplying, and we can't multiply till we do the exponent. Exponents always come first. So -1 squared, -1 times -1 is a +1, and we got that minus there. If you did it right, you should have got -4. Okay, now to answer the question, what are these two functions equal to if you multiply them together? Well, the first ones were 0 times the one we just got, -4. If we multiply those together, 0 times anything is 0. Looks like the answer to part B is 0. All right, there's one more part here, C. C wants to know what is g at 3x. Okay, this one's a little different still. Now we got a variable in there. Well, you do the same thing. You still want to plug in any where you see an x in that original function, which was 3x minus x squared. Anywhere we see an x, we're just replacing it with what's ever here. So you're gonna, wherever there's an x still, you're putting parentheses, and you're just replacing that with this. So the x is gonna become a 3x. And now again, you just simplify. 3 times 3x is 9x. Minus, here we got to square this stuff, so 3 squared is 9. X squared, we also have to square, that'd be x squared. We can't subtract these because these are not like terms. So we would just stop right there, and that would be our answer. All right, the other part we're going to look at is specifically linear equations or linear functions. A linear equation has no other operations other than adding, subtracting, multiplying by a variable, multiplying a variable by a constant. A linear function has ordered pairs that satisfy a linear equation, and any linear function can be written like this: f of x equals mx plus b. You probably saw this in Algebra 1 and geometry as y equals mx plus b. Same thing, it's just that I remember f of x is the same as y. Okay, another way you can write linear function is in standard form, which would be ax plus by plus c, where a, b, and c are constants. Constants are just like numbers. Okay. We want to be able to also, on these linear functions, which means straight line, linear line, straight line, is find the x and y intercepts. X-intercept is where it crosses the x-axis, and the y-intercept is where it crosses the y-axis. Okay, so let's find those out here. On this graph, it would be right here. It would be your y or x-intercept would be at 4. Your y-intercept would also be at 4 because that's the locations where it crosses the x-axis. Okay, these next ones are going to ask us, are these functions or not? Or I'm sorry, are they linear functions or not? So number 4, is this a linear function? F of x equals 3x. Yes, this one would be. Okay, and the reason why we know it is it looks like this right here. Y equals, our slope is 3, and we'll talk about that more in the next video. And our y-intercept, they don't list it, but it would be 0. So it's in that form of slope-intercept form. It's just really y equals 3x plus 0. Okay, let's look at another one. Number 5, is this one linear? This one, no. The reason being we got a number and a variable, which is fine, but it's the location of our variable that screws this up. You can't have division by a variable in a linear equation. Let's graph it out to show you. Watch what happens if we graph this one out. So we'll graph out 7 divided by x. If you look at this graph, you can see it's curved on there. That's not a straight line like we want. Here's a better view of it. You see the curves going on. You can't have a linear equation that has a curved part to it. So definitely not linear. Let's look at one last one. Number 6, is this one linear? We would say on this one, no as well. The reason, the variable has an exponent. If you start dealing with exponents on variables, not going to be linear. We'll talk about these later in the year. If you graph it, we can tell too, x to the 4th power minus 5 here. If we check out this graph, whoop, I screwed up. Make sure when you're graphing these, if you hit the exponent button, you got to make sure you hit over on some of these calculators. So x to the 4th, I got to hit over, then minus 5. Even so, we see this is a curved graph, not a straight line. And that's because of this power of 4 here. All right. Number 7, they want us to graph this and then find out what the x and y intercepts are. You can find the x and y intercepts on these by doing something called the cover-up method. Okay, and the cover-up method is basically another way of saying we want to find where it equals 0. Because if you look back at what we talked about with x and y intercepts, on your x-intercept, this is at 4, but it's really the location of 4, comma 0. Okay, it's an ordered pair. This is the ordered pair 0, comma 4. So we can place these zeros in for x and y, and that'll tell us where the intercepts are. So if we put a 0 in place of this y here, okay, 4 times 0 is 0. That's just not going to be part of our equation anymore. So if we cover it up and solve the rest of it, you can find the x-intercept. So now you got 3x plus 12 equals 0. If we solve this, we'll know where the x-intercept is. Minus 12, divide by 3, and you get negative 4. So there's our x-intercepts at the location, negative 4, 0 on the x-axis. Let's do the same thing and find the y. So here we'd put 0 in for x and solve what this would be with y only left. So again, minus 12, divide by negative 4, and it looks like our y-intercept's going to be at 3, or 0, 3. Okay, now to graph those, all you got to do is connect these with the line, and you got the equation of the graph. Okay, it's one method of graphing. We'll kind of review another method here in a little bit. Okay, now looking at this, just looking at it, it looks like I screwed up a little bit here. Maybe some of you caught it while you were watching. I put my x1 in the wrong spot. That was positive 4. We don't want positive 4 here. This was a negative 4. We want to make sure it's over there. So actually, it should look like that. So if you had written it the other way, correct that. That was my mistake. All right. This one. See if you can pause the video and graph this one out by doing the cover-up method. What's the x-intercept, the y-intercept, and then graph it out. All right, let's see what you got. X-intercept, okay, that would be covering up the y. Okay, now if you cover up the y here, you got 3x minus 9. There's an equals there, but there's nothing on the other side of the equals. Remember, by covering it up, we're really putting 0 there. So you got to solve it equal to 0. Add 9, divide by 3, and it looks like at 3, there's a point. Okay, the y-intercept, Now you're covering up the x part of it. Looks like that one's super easy. It's just y equals -9 because there is nothing even to solve. That would be right here. To graph it now, connect those. So if we connect these, that's what the graph should look like. Now some of you remember this is in slope-intercept form. We'll review that in the next one a little bit. -9 is your y-intercept. The slope is 3. And if you look at this one, it is a slope of 3. Up 3 over 1. Up 3 over 1. Up 3 over 1. And it just keeps following that pattern. So that's another way you can graph that we'll review on the next video. So try your practice problems now and see what you get.